Assalamu alaikum wa rahmatullahi wa barakatuh. Hello primary 6. How are you today? Today we are going to talk about mass and weight. But first, let's remember what is meant by mass. Mass is the amount of matter in an object or the amount of matter that an object contains. But how can we measure mass? Mass is measured by many tools which are called scales. These scales are divided into two types, which are two-arm scale and one-arm scale. In case of two-arm scales, there are two forms of two-arm scales, which are balance scale, which is called common balance, and it is used to measure large masses like the mass of fruit and vegetables, and sensitive scale, which is used for measuring small masses like the mass of jewelry or chemicals. In case of one-arm scale, there are two forms of one-arm scale, which are digital scale, in which the value of mass is resulted in form of digits, and scale with pointer, which contains a pointer that refers to or indicates to the value of mass. But what are the units of measuring mass? Mass is measured in 3 units, which are gram, kilogram, and ton. Gram is used for measuring, or it is the unit of measuring small masses like the masses of jewelry or chemicals, and 1 gram is equal to the mass of 1 paper clip. The second unit is kilogram, and 1 kilogram equals 1000 gram, and it is equivalent to the mass of 1 liter of distilled water. And the last unit is ton. Ton is the measuring unit of very large masses like the masses of cars and very large loads. Mass properties. Mass is a constant value and it doesn't change by changing the place. So, for example, if you measure the mass of your body on the Earth's surface, and it is, for example, 60 kilogram, then you measured your mass on the moon's surface, you will find that it is the same. It will be also 60 kilograms. So mass doesn't change by changing the place. Second, anything has a mass, whatever its physical state. There are 3 states of matter, which are solid, liquid, and gas. In the following figure, there is a piece of ice or water in case of solid state, and liquid water and water vapor. All of them has a mass, okay? And the mass doesn't change by changing the place, and anything has a mass, whatever its a physical state. The last property is mass increases by increasing the amount of matter in an object. If you observe the following book, this book is made up of paper, and these books are made up of also paper. While the mass of these papers of these books is larger than the mass of this book. Why? Because the amount of matter which is paper is larger in case of books than only one book. So by increasing the amount of matter, mass increases, okay, and vice versa. The second part of our lesson is weight. What is weight? To know the concept of weight, let's imagine that you have a ball and you throw this ball upwards. You will observe that after throwing these balls upward, these balls will fall down again towards the center of the air. That's why, because there is a force that attracts these balls towards the center of the air, this force is called weight. And also, when you jump up, your body falls down. That's why, due to the effect of weight. So weight is the attraction force that attracts objects towards the center of the earth or towards the earth. But in case when you are in a space, When you are in space, there is no effect, there is no gravity. So you are in case of weightlessness, or you have no weight. What are the weight measuring tools? The tool that is used for measuring weight is called spring scale. This spring scale, as we can see in the following figure, has two hooks, one upper hook and bottom hook, and there is a scale between them and a pointer. We hold the spring scale from the upper hook and we hang the object that we want to measure its weight in this hook, and there is a pointer that points to the value of weight on this scale, and the distance or the extension of this pointer refers to the value of weight of the object. But what is the unit of weight? The unit of weight is called Newton, and it refers to the scientist Isaac Newton, who discovered the gravity. So weight is measured in Newton, and the Newton is the weight of an object that its mass is 100 grams. What are the factors affecting weight? There are three factors which affect the value of weight. These factors are, first, mass of objects. As the mass increases, the weight increases. Okay? The second factor is the planet on which the object exists. As we can observe in the following picture, if you measured your mass on the moon surface and on the Earth's surface, you will find that your mass is the same, because mass doesn't change by changing the place. But in case of weight it changes by changing the place, because the value of the attraction force of the planet differs from one planet to another. Okay, the third factor is the distance from the center of the planet. As the distance between the object and the center of the planet, where the center of gravity, as the distance increases, the value of gravity or attraction force decreases. So as you go upward away from the center of the planet in which you are existing, the value of attraction force or the value of your weight decreases. But how can we calculate the values of weight? There is a law. This law states that weight on Earth equals mass times 10. Weight on Moon equals mass times 10 times 1 over 6. Because the mass of the Moon is less than the mass of the Earth planet 6 times. So the attraction force of the planet, of the Earth, is larger than the attraction force or the weight on the Moon surface. So if your weight on the Earth's surface is 60 Newton, for example, so it is expected that your weight on the Moon surface will be only 10 Newton. That's why, because the attraction force of the Moon is smaller than the attraction force of the Earth 6 times. Problem? If the mass of an object on the Earth's surface is 6 kilograms, calculate its mass on the Moon surface and its weight on both surfaces of the Earth and the Moon. Solution? Mass on Earth is the same on the Moon, so it doesn't change, because mass doesn't change by changing the place, so it will equal 6 kilograms. Weight on Earth equals mass times 10, so it equals 6 times 10 equals 60 Newton. while weight on moon equals mass times 10 times 1 over 6, which equals 6 times 10 times 1 over 6, which equals 10 Newton. That is